Hello, this is Lori Benoit from the University of Louisiana at Monroe. I will be um, doing Module 4's discussion board for Curriculum 7004 with Dr. Vista. I'm using IBM SPSS for Intermediate Statistics by Leach, Barrett, and Morgan. This is the 5th edition of that work. I'll be drawing heavily from that work, so I want to make sure to cite it up front. Our question of the week is, are there differences in math achievement for people varying on math grades and or father's education revised? And we're going to be using a two-way ANOVA or a factorial ANOVA to do that. So I'm just going to get started here and show you how we're doing that. We're going to go to Analyze. So I've pulled up my data set, which was provided within the module. And I'm going to go to Analyze, General Linear Model, and Univariate. I'm going to move math achievement to the dependent variable box. Notice it is scale. And then I am going to move the first independent variable, which is math grades. So right here, to the fixed factor box. And then I'm going to move the second independent variable, which is a father's education revised, to the fixed factor box as well. I'm going to just double check that I've done that correctly. And now that we know the variables we're going to be dealing with, we're going to determine our options. And at this point, we are ready to begin moving to the next step. We need to click on, if you look over on the right-hand side, this is plots. And we're going to be moving the father's education revised to the horizontal axis and math grades to the separate lines. And from what I can tell and from what I've read, we could actually put these in either way. The book, however, recommends this way. Apparently the plot is going to come out cleaner when we do it that way. So I don't know if we would actually have, we would probably have to find this out ourselves with our dissertation through trial and error, but it's nice to have the tip for now. At this point, we're going to press add right here. And notice that they have dropped down into the plots box, and you want to double check and make sure that those are there. Also, you notice that we have line selected here automatically. That is the type of plot that we want, so that works. At this point, we're going to click continue. And it's going to take us back to this box, our main box, but we're not quite finished here yet. We have to select options, and then this is where we have to make sure some things are displayed. My version of the book says descriptive statistics, estimates of effect size, and observed power should be selected. Also, right here on the right, we need the homogeneity test selected as well. Once we've done that, those are the only things that the book indicates that we should be checking for. And we can hit continue. And our significance was set correctly as well. At this point, we click on OK. And now should be getting our output pretty soon. Excellent. So it has generated now. And for this portion of it, I'm going to be drawing pretty heavily from the book to help me. I don't feel as confident interpreting some of this stuff. So We can see that we have 43 participants indicated here for the A, B, and 30 for the most A and B. And if you just kind of check over these N values, we can see that it's what we had in our data set. So we're accurate at this point. When we get down to descriptive statistics, which is the second table, it's going to show the cell and marginal means, and both are very important here for interpreting the ANOVA table. So this top portion, the less A and B, that's actually going to be one line on the plot that is generated, the line graph that's generated the plot. And then this is going to be the second one, most A and B. And what's kind of interesting here, and we're really going to be able to see it when we see the lines, is when we look at these means, we can already see some statistical significance emerging here. The mostly A and B and the father's education level, we can see that increase is already taking place by just examining these means. The next important thing that we get from the output is the Levine's test of equality of error variances. And so I really, for this portion, I'm going to be drawing heavily from the text. They pointed some things out that were pretty important. And so I want to make sure to mention it. Most importantly, and this is what our book points out, and I'm still trying to understand why this is so important. I feel like I have a good grasp of it, but this indicates, so right here when we see the significance of 0.036, this indicates that the assumption of homogeneity of variances has been violated. Because Levine's test is significant, we know that the variances are significantly different. Luckily, SPSS uses the regression approach to calculate ANOVA. So this problem is less important. And that's the part that I'm kind of learning to understand here. But the book suggests that we should definitely see that this is a violation that should be considered when deciding which post hoc test to use. And so I think that that's more important with what we do with this data, and just looking really closely, basically just kind of like a little flag that this was violated. So we need to remember it when we do further testing and of course in our interpretation. So that's something I definitely want to remember for my dissertation. As we move on to the next piece of data here, we've got the tests of between subjects effects. And this one is very interesting because when we look right here, this is where we're going to get that partial eta squared. And we see that this indicates the proportion of variance in math achievement that's due to the father's education and not just random differences between people in math achievement. And it's going to be right at 24%. So that's a lot. That's pretty significant. There are some other data points here that are pretty significant. So the book indicates that we need to be looking here, focusing on these 3 F's and the significant values. And we can, once again, when we kind of trace that, we can see already in the data points that the significance is showing up here in these, what we call this interaction. It's already happening. And then of course we're going to get the plot, and that's where it becomes, there's nothing like a visual to really make the numbers speak, so to state. So if we look at this top line, we've got math grades that are this very top one is the most A and B. And then this lighter blue one, this bottom one, is less A's and B's. And so as we move on this horizontal axis down at the bottom, notice that as we move to the right, the father's level of education is increasing. And so what we notice is that this very first one where it says high school graduates or less, there's not a lot of variance, a little bit, but not a lot of variance. But as we increase to these next two levels, some college and then bachelor's or more, so college graduate or more, this is when we see the huge gap in achievement. And it makes me, what this really made me think of so much is, our students in our classrooms, and we're not just teaching that student, we're teaching the student's background. We're teaching where the student came from. So that, I think that's why that was so meaningful for me. And I am going to very quickly, didn't I didn't use all of the results that were present in the book. The book goes on and does another test, and I didn't include that, but I did include just kind of a little write-up of the results. Kind of wanted to make sure I understood it. And essentially, the results indicate that students who had mostly A's and B's in math were associated with high father education. So the effect size is considered large here. Well, that's it. Thank you very much. I appreciate your attention, and I hope you have a great week.